Ladies and gentlemen, it is 3 p.m. 3 p.m. in the beautiful city of Noordwijk in the Netherlands. We had snow over the weekend. It was fantastic, beautiful. All of us are full of energies. I can see Peter from Sylex is super happy today. David from Arnaud and Remco from Somni. We are a great group of people looking to do business on the fiber world. The floor is for the Epic members only. Okay, welcome to a brand new year full of exciting opportunities. Recently, we had spectacular meetings looking at real-world applications for specialty optical fibers, like photonic crystal fibers, heavily multi-mode fibers, fibers capable of transmitting mid-infrared light, ultra-thin fibers. Fascinating. Now I want our end users to dream big because we have the active Epic network to make great things happen soon. But it takes a wild dreaming end user to have a real technology breakthrough. So who are the candidates in 2021 to become the Elon Musk of a specialty optical fiber? So let's be inspired by users, including the European Space Agency or NASA. I believe an example of dreaming big is printing high-performance C-band fibers in space. It's the path to get unique fibers with broad wavelength range and low losses made to withstand the harshest environments in the universe. And let's keep dreaming big in medicine, where combining laser technology and ultrasound means safer, efficient removal of blood clots in hearts and brains. Minimally invasive procedures are emerging now, involving specialty optical fibers and 532 nanometers blue lasers. So imagine a world where nearly all medical procedures are minimally invasive and no more cool scars are left on our bodies. Photonics enables patients to go home on the same day. But wait, there is more. Real-time monitoring of the car engine, learning from and preventing disasters like the Genoa Bridge, enabling a standard detection of explosives and hazardous materials. Many dreams are becoming reality. So why not share your dreams and photonic solutions? Our Epic Online Technology meeting begins at exactly 3 p.m. on Monday, January 18th. Sign up to participate or follow online in the Epic YouTube channel, real time or anytime. Being Epic means never stop dreaming. Thank you very much for listening to this. I love making these videos. I'm having so much fun. I would like to say that it took a lot of work to make this meeting happen. And I would like to send my deepest thoughts to Dr. Elena Beletkaia, who can't be here today, but she worked really hard over Christmas to scout some of the amazing companies that we have today. Elena, we are with you, all the strength. We're growing and we keep growing. Epic has now 660 members, so thank you for all the great support, and also on behalf of the fantastic team that the Epic staff complies. 15 people, 7 PhDs, people who have experience on all the markets, on all the technologies, on the marketing side, on the market analysis side. We are here for you. And just to remind you, we help you raise capital. We help you find a job in photonics. The biggest website to find a job in photonics is www.jobsinphotonics.com. And the most important, we connect companies. That's what gives us all the energy. We connect companies in events, but also with the email introductions, which we love. And we are already in the Chapter 3 of Season 3 of the Epic Online Technology Meetings. Today, fiber sensors. I would like to remind all of you that if any of the upcoming topics is relevant for you, and for example, pay attention to the one that we have on robotics on the 1st of February, please register online as soon as possible for this meeting. Super important that you do that. Let me stress that. Register for the meetings that are relevant for you. And also, would like to remind all of you that in 2021, we started our quantum life as well. I love quantum technology, so this is so fascinating for me. We're also organizing online technology meetings only on quantum technologies, and this is the calendar for the upcoming quantum technology meeting. So if you want to know what quantum is, or you just have a business in this technology, or you have something cool to show at these meetings, let us know. We are really super excited with this happening, and that's it. That's all about Epic. Today is about specialty fiber and fiber sensors. First of all, I would like to acknowledge the support of our media partners, Medical Device, Electro Optics, AZO Optics. Thank you very much for all the great effort you're doing for promoting what Epic does. But most important, this meeting couldn't happen without the support of our sponsors today, OFS. OFS is a premier global supplier for innovation in optical fibers, cables, assemblies, and modules. Actually, you should check that they launched the acoustic sense fiber for distributed fiber sensing, one of a kind. FORC-Photonics. FORC-Photonics is an expert and manufacturer of different types of fiber grading, specialty fibers, and high temperature sensors, especially for the harsh conditions. Modulight, all the way from Tampere in Finland. This company makes MBE growth of semiconductor lasers, from the wafer all the way to deploying these lasers in clinics. The entire supply chain comes the manufacturing, the packaging, the assembly, and the instrument. One example for the European industry. But if we go to Slovakia, we meet Sylex. It's one of the biggest European fiber optic assembly and FVG sensor manufacturers. They are expert on the FVG sensing and also in the datacom telecom. Any sub-assemblies of fibers, you go to Sylex. Any specialty fiber, you go to Sylex. And I want to finish with one of my favorite companies in the whole wide world, FORC-Photonics in Berlin. You know, they were launched in 1998 just to develop a specialty fiber for a very broad range of wavelengths. They go from the UV and the mid-infrared. And lately on the market of medical, they are really excelling. You're looking for a partner of mid-infrared fibers, you go to FORC-Photonics. And if you're looking for a fantastic R&D manager, don't look for Ana Gonzalez because she works for Epic and I don't want her to leave. Ana, what's in the menu today?
Hello, everyone, and thank you very much, Jose, for this nice introduction. So yes, I am very happy to be here today to talk about the specialty fibers and fiber sensors. And well, today you can see we are going to talk about emerging applications using fiber sensors, such as in the space market and in the medical market, among others. So yes, regarding companies that are attending and are ready to participate into the discussion, thank you very much for this registering. Today we have a great supply chain. At Epic meetings, we want to take into account the needs and challenges of end users of the technology. So today we have a great list of end users in the room, such as Airbus, Vitesco, ESA, Paradigm, and Andra. And then we have other levels of the supply chain, system integrators, companies making fibers and cables, lasers, instruments. We have the big ecosystem in the room, also companies doing software, metrology, micro optics. And finally, I would like to mention the pylon lines in photonics participating in this meeting. These pylon lines are working together, developing standard solutions for manufacturing of PICs. And they are JPICS pylon line, which offers large volume manufacturing of indium phosphide chips, also PICSAP for the packaging and assembly of these chips. Then very related to the supply chain for PICs, and well, we have Fabulous that is working in high volume fabrication of free-form micro optics. And related to the applications, we have MedFab, the pylon line for fabricating medical devices, including medical regulatory considerations, and PhotonHub. PhotonHub supports European companies that are not expert in photonics and want to increase the TRL of their new products that are based on photonics before to make a big investment. So that's it, Jose, back to you.
Muchas gracias, Ana, all the way from Barcelona. Ana is the expert on finding ways of getting the European Commission supporting the manufacturing production of photonics. So if you have a challenge on your supply chain to scale up to production, contact Ana for any technology. This slide over here is beautiful. It only represents the companies that registered for today's meeting. So you're an Epic member and you think your logo is missing here. That's only because you didn't register. We never forget about any of our 660 members. And this meeting is broadcasted live in YouTube. So hello, YouTubers. If you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-azo.com, and I will make the introduction. Please feel free to also use the chat to post any questions. And this is also valid for the people in the Zoom room. If you want to get in touch with each other, use the private chat in there. You can actually already talk to you while there are other people presenting. And also, please remember that after the meeting, if you want to get in touch with any of the participants, drop me a line, send me an email, jose.pozo@epic-azo.com, and I will love to make that introduction. Let's get the meeting going. That was an interesting introduction, right, Ana? Let's get the meeting going. And today, to be honest, when we arrange this kind of meetings, we learn a lot. We wanted to start with something really innovative, the most innovative things in fiber. So we went to NASA and we asked them, what is the coolest thing that you have seen? And they told us, do you know Made in Space? And we couldn't believe our eyes. Louis Schlegel you're gonna make fibers, Zebland fibers, in space. That's totally crazy, but we need crazy people to dream big. Luis, the floor and the attention of everyone in the Epic network all over Europe and the world is yours. Luis, good afternoon. It is actually 3 o'clock, 3:10 in the Netherlands. What time is it over there?
9:10 a.m.
Good morning.
All right, so my slide, Anna, my screen's up.
Yes.
All right. Well, I'm so happy to be here. I actually went and got a second cup of coffee, you can see it, because I was trying to keep up with Jose because he's so animated. Don't know that I'm going to do that, but I'm going to try to splash it with a little bit of flavor to keep the dialogue going, because I got to follow Jose, and he must have had 5 or 6 cups of coffee. All right, so it's so exciting to be able to come here. Made in Space has been in business since 2010. You know, one of our product segments is we manufacture materials and products in microgravity on board the International Space Station. The beauty of this is we get to come to this event and share some new information about our work on fiber optic materials and specifically Zebland. So microgravity provides a very unique environment. You know, absent of solute convection, thermal convection, buoyancy-based sedimentation, and these elements create defects in products, specifically in Zebland, because the materials don't cooperate together. So I'm here to say today, our first announcement outside of the company, well, I can say it if I can click my button, is that we have been pulling fiber optic materials since 2017. We're now going to move into commercial production beginning next year. And so with this audience today, we just ask that you start to envision what type of applications can really expand the application throughout this industry in terms of sensor applications and so forth, to have a steady state supply of material. And it's going to have some growing pains. You know, we'll produce tens of kilometers of material per batch and then expand the capacity. But I'm here to say we're going to start production in 2020. And I'm reaching out to this group on behalf of Made in Space to ask, you know, if you have interest in evaluating our material, or you'd like to discuss collaborating towards a new material, then, you know, take a note of my email address. Just reach out to us. I have a email follow-up to ask you a few questions and start to collect some information on companies that are interested in the material, and that we can be able to come back in about 8 to 10 months to re-engage, to do an NDA, to start sharing more information. So, you know, the exciting thing is this industry is now going to start to see commercial capabilities and volumes of Zebland and other exotic fiber optics manufactured in low Earth orbit. And I'm open to questions right now.
Thank you very, very much, Luis. This is one thing that we always ask our members: dream big, and you definitely dream big. The first question comes from me. This is an epic meeting. We are looking for collaborations, but before that, something that is in my mind, I need to ask, why making the fibers in space?
Oh, why manufacture exotic fibers in space?
Yes.
There's inherent challenges trying to make terrestrial Zebland. You know, it's composed of 5 different materials, and when you begin, and they have different characteristics, and when you begin to pull them, they don't behave very well. And at best, you might get small sections of usable material. And now we're talking essentially a defect-free Zebland material that's manufactured terrestrially. Again, we've been doing it since 2017 and have optimized the equipment. And now we're scaling up to make our first production machine. And the benefit is it's been studied since the 1980s by the Air Force as a material that really has a compelling business case for manufacturing in low Earth orbit. And I can say that comparing apples to apples, manufacturing Zebland and other fiber optic materials in microgravity are much more economical and lower cost than doing it terrestrially, which is a first.
Thank you very much. I'm going to introduce you to some of my companies here, but first I want to give the floor to Lever Flore. Samuel, what's on your mind?
Hello, everybody. Yes, I've got several questions. How long fiber you're able to draw now? Because I know that you have made some trials in ISS, but I'm curious about the length of per batch on of course, the background losses.
Yeah. So your question is, what are the length or the volume of material we're going to produce?
No, you are producing now.
No. We've been using our prototype machine. We've been examining optimizing the capabilities of the machine to pull it in commercial volumes or production volumes in low Earth orbit. And you can imagine with a few companies that are trying to do the same thing in low Earth orbit that in this forum, we're not able to give out any detailed mechanical properties other than the known benefits, which is significantly 2 orders of magnitude lower in attenuation loss and being able to go out to mid-IR, things you may be fully aware of. But we're going to keep our production quantities and our specifications, close to our vest. And so, today, if we can just get a list started of companies that are interested in evaluating the material, and from there, move it into an application that might have some volume or length on it. We'll be initially providing Z-bland, single mode, bare, uncladded.
I want to help this company. I want to help because I get really goosebumps when I discuss with some of your colleagues. One of the rooms for cooperation that you envision is testing of the fibers. I want to introduce you to some of the companies that we have in EPIC. David from beautiful AZO Photonics, all the way from the UK. You saw the teaser presentation from Made in Space. They could perhaps find collaborations in the testing side. What stays on your mind, and what perhaps room for cooperation do you see with them?
Okay,
yeah,
if I
we
understand
make test equipment for all sorts of optical fibers. So yeah, possibly some special challenges that you have in measuring this product. So we'd love to hear about any special challenges that you have in that area.
When it comes to the Z-bland fiber, Luis, that you want to develop, do you have some specifications, some challenges when it comes to perhaps the different materials used or the testing? Is there anything that perhaps I can share with these companies and they can help you with something specific? One challenge.
Sure. And I've seen some of the questions pop up, and it's a closely guarded secret. It's a race. It's a race in space to be the first to manufacture commercial volumes of any material and product. Z-bland is obviously the one that has, again, for years been the most compelling business case because the cost to manufacture in low Earth orbit, coupled with the continuous decreases in the cost of launching the material. And we're talking about bringing it back 2 and 3 kilometers or kilograms of material at best per batch operation. So, the way we design the machine is proprietary. The way we address the radiation, the radiation in the environment, all unique to Made in Space. And of course, we go through rigorous design reviews with NASA to make sure we're addressing all the elements in regards to safety of the astronauts in the facility. But while I know there's many technical questions, we just really aren't in a position just to openly discuss it in this forum, other than to say, if there's an interest, reach out by email. Let's exchange a little information, and then we'll be in touch as we get closer to our first commercial lot to reach out and go into the NDA process, and then address all the questions.
Don't worry. You answer what you want to answer. I was aware of this. Don't worry at all, Luis. But I want you to meet the companies. This is what the purpose of the meeting is. So I'm going to go now to Lanyon. I'm going to go to iXblue. Nicephore, how are you doing today? You posted a nice comment in the chat. What room for cooperation do you see with Made in Space?
What kind of cooperation? No, it could be always interesting to understand more the benefits, I will say, to draw in space versus to draw on Earth. And especially my question was related to the radiation, because we know that in space, of course, there is some radiation. So how does it affect, I would say, the draw of the fiber versus to draw a fiber on Earth. So that was a little bit the idea behind.
Can you comment on that, Luis? Radiation dependency on the manufacturing of Zealand fibers?
Yeah. Excellent question. And again, to go into any depth of discussion, we've got to go into an NDA to keep all these elements protected. So
don't worry,
now's
Luis,
not
it's
the
fine.
time. It's early stage. Hey, we're going into production next year. Who wants to get some material? And let's start putting a plan together so we can address our initial wave of capacity demand.
One of the companies that has already been in touch with you, and they are one of the drivers of EPIC in the European market, is the European Space Agency. Iain McKenzie from Noordwijk, the Netherlands, representing ESA today. Iain, you saw the presentation. There is lots of room for cooperation. What's on your mind?
Yeah, it's very interesting. I think that clearly there are tons of challenges around it. And in particular, how to manage, the automation of such a system, because obviously man in the loop is going to be very challenging with, if you have to use astronauts. So this must be a truly automated system, without any requirement of human intervention. So definitely interesting. I think, the obvious advantage of space is the impact that it has on the thermodynamics and the fluid dynamics in microgravity. And clearly this is an interesting proposition, but I think it's probably a long way from being able to draw thousands of kilometers of fiber, which would be interesting for the terrestrial market. If you could have ultra low loss fibers, it could dramatically change the whole telecommunication field.
Yeah, amen. So I'm looking at some of the chat questions, and of course listening to you as well. And just wanted to say, as we transition to commercial production of ZBLAN, our current machine, which was developing the prototype material, is available and now to start configuring for other types of exotic fiber optics. So again, there's two paths. Who's interested in material, ZBLAN material, initially single mode bare, and who would like to have a discussion at some point to discuss the current machine to start the reconfiguring it to pull a different material. And one of the questions was, who draws the best ZBLAN in low Earth orbit? Redwire, Thorlabs, or foams, and I guess it's hard to say because no one's sharing their data, but the proof will be in the pudding. It'll be well characterized, and you'll see the applications. But for me personally, the biggest two of the biggest applications I'm excited about, and these are big volumes, is developing a next generation data center that uses that material. And of course, that means a lot of work on developing the complementary components that would utilize that data and so forth, being able to go out to mid-IR and transmit at different frequencies and so forth. So I think a data center would be an amazing application once our volumes are up higher, as well as underwater cable applications where, right now you do a repeater, it costs about $1 million, I think about $1 million per repeater every 100 kilometers. And now we're talking about no repeater for at least maybe 2,000 miles, maybe 2,000 miles before you need to refresh the signal underwater. So those are big volume applications. I think initially what would be useful for the global market would be to pursue applications in medical and other sensor applications where you need a smaller amount of material to characterize it, smaller accounts in production, and just get that initial material out in the market to start assessing the viability of the material for the applications you already work on.
Yeah.
And then working down the funnel to really hit some home run applications that'll look at a lot of demand, because we're able to scale and build much larger facilities to pull the ZBLAN. But one thing I want to close out with, on Earth, when you pull a silica, you pull it in a 3-story tower, and we can't do that in space, or we can't do it on board the International Space Station. We are currently pulling ZBLAN in a machine the size of a microwave oven. So a lot of innovation has required a lot of due diligence to be able to, instead of pulling in three-story building into a microwave size locker on board
it
the
is
space
quite
station.
one of the most impressive companies I have seen in the industry, and I have to say the sky is not the limit for made in space. There is one comment that I want you to listen to because it's from a company that I really love, ART-Photonics in Berlin. Slava, what's on your mind?
Thank you, Jose. Very interesting. In general, you know, I am familiar with 3 competitors doing the same stuff at ESS, you know, and yes, you are right. It's difficult to say who is better in the moment because data are confidential from every player, you know, but how do you assure that, let's say, highly hygroscopic and very fragile fiber can be drawn for thousands of kilometers and can be delivered from the orbit to the Earth and installed underwater, compared to the recent success in Southampton and other guys, when they really reached fantastic attenuation in silica fibers, which is anti-resonant and much more, how to say, robust material compared to fluoride glass fibers?
Sure, excellent question. And you know, the I don't want to say the threat, but the potential availability of Z-blend is certainly attractive to the silica side of the market. And so you're seeing innovations in silica to improve its characteristics as best as possible. And, you know, the data will determine the demand. And I understand that while everyone would love to see some initial data or get some glimpses of what we're doing, it's best that we keep it close to our vest and do it under an NDA at the right time. But again, sure, there's threats to every technology. And if silica is making some robust improvements, you know, it's still a race, and we'll just have to see where the dominoes fall. But
I don't really, yeah, all I want to say is that be prepared to get a lot of templates for NDAs out, because many companies want to be in touch with you, Luis. And you started the meeting the way I love it, with a beautiful discussion. Luis, the sky is no longer the limit, and Epic is here to help you. Thank you very, very much. And we're going to continue now in the space industry, and we go to my home city. We go to Northwijk. We go to Iain McKenzie from the European Space Agency. Let's make ESA even better than already is. The floor and the attention of everyone goes to you, goes to space.
Thank you, Jose. Yeah, it's my pleasure to join this this meeting. Thanks for the invitation. I would like to just maybe introduce some of the areas in which optical fibers are used in space here at the European Space Agency, because some of you might not be fully aware of what is done using fibers. And then maybe just go on to explain some of the challenges that we face in using fibers in space. And then finally, some research work that's been done over the past, and maybe we can think of some future applications as well. So if I just, this slide kind of goes through the kind of key areas where fibers are being used in space today. And I start with the fiber optic gyro, because this is maybe one of the best success stories of a fiber sensor in space. Today, they're flown on tens of satellites. And we have a fully European space qualified fiber optic gyro family, which has been qualified by iXblue and Airbus together using ESA and CNES funding. So in such a gyro, you have 2 different types of fiber. You have, of course, the rad-hard erbium doped fibers, which are part of the source. And in addition, you have the sensing fibers, which are the long lengths of fibers, in this case, polarization maintaining fibers, that are part of the interferometer. So beyond this, we've also got, since 98, there have been fibers flying on the International Space Station. Quite a large number of cables for data communication have been installed on the ISS. And some of the challenges here are being able to operate over a very wide thermal range from plus 100 to minus 100 degrees C. Beyond this, in 2009, we flew a synthetic aperture radiometer called SMOS. And this used for the first time a network of optical fibers to distribute both the clock to the L-band receivers, but also for the data communication. And in future, we will continue with digital communication, and many of our telecom satellites will fly digital telecom processors, which will have an optical backplane. And the data rates on these optical backplanes will be starting from next year. I think will be the first flight at 12.5 gigabits, but going up to 25 gigabits and beyond, even to 56 gigabits. And currently we're working on digital communications for space in that regime. You probably heard quite a bit about optical communications in space and the use of optical terminals. And TSAT is a company located in Germany who has developed, that's the first kind of operational commercial system called EDRS, which is a European data relay service. And here these terminals also use erbium doped fiber amplifiers to amplify the signal, and depending on which wavelength, they can be either erbium or ytterbium amplifiers. In 2009, also on Proba 2, we flew our first demonstration of a fiber optic sensing system based on fiber Bragg gratings. This is still successfully flying today. And in addition, MPB, located in Canada, also flew on a re-entry vehicle for DLR, Chef X2, where they used high temperature sensors, including gold-coated fibers with Bragg gradients written into them for doing high temperature measurement of re-entry systems. I include here also the work that's currently ongoing on developing Optopyro for the Ariane 6 launcher. Here we have a system to ignite rockets, to separate stages, a complete system for the launcher based on an optical fiber and laser ignition. So let's just quickly go on to some of the challenges. And I use this example because it's something that I've been involved in recently, which is the mission, the JUICE mission, which is an ESA mission which is due to be launched shortly to visit Jupiter and its moons. And part of that, part of the instruments on that particular satellite is a scalar magnetometer, and it's based on an optical technique of looking at absorption in a gas cell. And by doing this, we're able to measure very accurately the magnetic field in terms of its magnitude. But in order to deliver the fiber to where the gas cell is located on a 10-meter long boom was an extremely challenging task, because it required the development of a custom optical fiber able to survive in that particular environment. And just to give you an idea of this environment, you have to look at the radiation dose that this will receive. And over its cruise, which has got a long cruise, and then it reaches the Jupiter environment, where it's a very high radiation environment, the total mission requirement goes up to 20 megarad, which is a huge amount. And particularly when you consider low temperatures. And you see this, this chart of radiation-induced attenuation, and you can see that you can get pretty severe attenuation when you expose an optical fiber, in this case a silica optical fiber, to radiation. And it gets worse the colder it gets. And which then comes to the second point, which is the thermal environment. And here we have to design a cable that will survive from minus 190 degrees to plus 100 degrees. And of course, this produces a lot of other issues as well, such as thermal shrinkage and you know, when you design a cable, typically the materials have different coefficients of thermal expansion, and this can lead to losses in the fibers. So this was a huge challenge in this particular case, to try and design a cable that would be able to survive in this environment. And then beyond that, of course, you still have shock, And if you compare this to a typical terrestrial application, I mean, telecardia, we typically have shock tests up to about 500 G. And so here you can see that we're considerably higher than this. Random vibration is around what you would expect for typical terrestrial applications. But then you have the additional complexity of designing something that will also be compatible with a vacuum environment, which means low outgassing. So this is just to give you an indication of some of the challenges, and I show you some test setups that have been used in this particular case, and you can see the radiation testing performed by Fraunhofer in the bottom of the slide, which shows a cryostat coupled together with a gamma source. Bottom right, you see the boom deployment test at ESTEC. Top right is 3 coupled thermal chambers, because in order to simulate this, we had to simulate different thermal environments covering, from out on the boom to inside the satellite. So these all add a lot of complexity to both the design of a custom cable for this application, but also gives you an indication of the kind of environment that we're facing when we try and develop something for space. Okay, so now go on to some research areas that that we've carried out here at ESTEC, and here you see some examples. There's a development together with FPGS of a high temperature pressure sensor. And here you can see some microstructured fiber designs that we tested. And in the end, FPGS was successful in developing a downhole design from this. So it's kind of spin out technology from what we had been developing for our space applications. Another example is a cryogenic sensor developed by TNO based on FPGs, but as some of you might be aware, as you go down in temperature, the responsivity of the FPG actually decreases. And in order to enhance this, TNO came up with some very clever coatings. And here in the picture, you see them being tested in a cryostat. Today, we're currently working on improved rad-hard ER-doped fibers for frequency combs, developing custom designs with the correct dispersion required for these. This is together with Menlo and iXblue. We've also had a look at hollow core fibers, and these were mentioned just earlier by in the discussion, where there are huge advances in the performance of these hollow core fibers, and clearly they've got an interest for not just terrestrial applications, but applications such as fiber optic gyros, and we've done work with Thales, iXblue, and iXlim on this type of application. Finally, it mentioned the Darwin mission, even though this mission is no longer one of our current missions. But here there was a very interesting problem where we wanted to create optical nulling of a star so that we could look for planets around that star. And here you see a photograph of a far infrared optical fiber, terreolite optical fiber, developed by the University of Rennes. And this was to create a single mode operation covering 4 to 20 microns. That was the requirement. So, and beyond this, there are really interesting future applications coming up, and there's discussion ongoing to look at, seismology on the moon, for instance. Here, the interest would be to have a 4-kilometer length of optical fiber on the moon, deployed by robots that would be able to measure seismic events on the moon. So that's a good example of a type of new cable that we might need. We're also very interested in how distributed sensing can be better used. We've seen papers from NASA on how these can be used in future inflatable structures for humans. So there's a lot of excitement about what can be done in terms of using this fiber technology in future exploration, especially as in the next 10 years, we plan to send the first woman to the moon and, return men to the moon as well. So at ESA, we're open for collaboration. You can visit our industry portal and learn how to do business with ESA. Beyond this, it's also could be interesting for you to come and join us at the International Conference on Space Optics. This will be taking place online. It's a virtual conference starting on the 30th of March. But this is a biannual meeting which allows an exchange of information and ideas covering all aspects of optics and photonics. So we hope you can join us there, and we look forward to you being part of the next 50 years of ESA activities in space. Thank you, Jose.
Thank you very much, Ian. Very, very nice presentation.
Thank you, Anna, as well.
Yes. So, okay. So when you think about going to Jupiter, in addition of the radiation that apparently you have it under control, there are other challenges that you would like to explore for potential collaborations with the companies here.
Well, for that particular Jupiter mission, we have a cable. It's already been qualified. It's kind of a closed story, you could say. But definitely there are future applications like the one on the moon, where we desperately need, say, a lightweight cable that could be reeled out 4 kilometers by a robot that can survive huge thermal variations. These are challenges that we can put out there to the fiber optics community to see if they can answer our call.
Okay, thank you very much. Now I would like to give the floor to Fabian from Omnisense. That I think Fabian can see a potential collaboration here. Fabian, would you like to talk?
Sure.
Hello.
Well, good morning, good afternoon, everyone. So, well, definitely that's very interesting to hear that distributed sensing has a future on the moon, not only on Earth. And well, there is a good potential there is a good bunch of information that you can grasp from temperature, strain, and vibration sensing. All of them distributed over the line, over the fiber. So we at Omnisense we have we manufacture distributed temperature, strain, and acoustic sensors. So we definitely believe that there is something we can do with your or in your project. Yeah.
Great. We look forward to hearing more.
Fabian, it works both ways. You know, in this kind of work, I want to make sure that ESA uses your fibers, but I also want the EPIC members to help Omnisense. So Fabian, could you share with us one challenge, one room for cooperation, one thing that a company could help Omnisense? I know you have been deploying fiber sensors in the oil and gas, in the defense, in the telecom, even better than already is.
Well, looking at what EPIC is doing is great, definitely. You are really on the frontier of optics. I like a bit the conference a few years ago that was organized in the US. And actually what we are currently as a company, we are, let's say, always discussing with people who don't know what photonic is. Even many of them don't know what a photon is. So we deal with very with an industry, with industries, because just not one, but with industries that are very conservative. And the step, and I'm not talking only for me, I think I'm talking for all the fiber optic the distributed equipment and the distributed fiber optic sensors manufacturers, we all face the same challenge. It's talking to people who are not really familiar with photonics, who are very often reluctant. And the step is, well, making them much more than just aware of the technology, but demonstrating that it brings value to their operations, essentially. So how does it improve the operation? Is there cost saving? It's always the same story. Is dealing with people who wants to hear, well, it will cost us less to operate, to maintain, and of course, capex must be as small as possible. So that's the challenge we all face. It's really dealing with people who are great, but a bit conservative on the use of that kind of technology.
You're doing pretty well. We met many of your colleagues when we could travel. We met many of your colleagues in our event in Saudi Arabia, and we understood how crazy conservative this world is becoming. Mm-hmm. But I also love when companies are innovating like crazy. So I'm going to go to one of our members in Portugal. HBK Fiber Sensing has been one of the companies that has been really at the edge of bringing new applications for fiber sensing world. Luis, thank you very much for being with us this afternoon. We have a lot of room for cooperation in the room. What are your expectations for this meeting, and what perhaps challenges do you have for companies that could help HBK Fiber Sensing being even greater?
Hi, Jose. Thank you very much. It's nice to be here, and thanks for bringing this event up. As you know, we planned to have one live, real, physical in Porto, and we had to postpone it. So it's really nice that we are able, at least in this way, to get together. So I see lots of challenges for optical sensing for 2021. I mean, to start with one very obvious, which is every time we are requested to go out for an installation, it's a really tough task nowadays. So, but in terms of optical fibers, you know, there are an incredible amount of new optical fibers with great features. But if you think that using a silica optical fiber, standard one with FPGs, it's already so challenging in terms of make it standardized and to have products based on it that are fully understood by all the users, that I mean, immediately you see that if you bring anything even more complex based on more complex optical fibers, you have two challenges. You have the market, you have to bring it to market, you have to make products that everyone understands, and you have to make interrogators for those special type of sensors. So that's not easy. So that's the challenge. For one hand, you open opportunities, you open possibilities. On the other hand, you have to make them usable, let's say. So that's my 5 cents, let's say.
Okay, thank you very much, Luis. I cannot wait to go to Porto for this meeting that we had to delay. Okay, so now I have another question in the chat. Peter from Sylex. Hello, Peter, hello.
Yes, hello, I'm here. Sorry, I was a little bit getting troubles to get myself unmuted. I wanted to point a question on the end regarding the need and potential challenges that would ESA see in terms of strain sensing in terrestrial and in-space operations. Something we can also, of course, discuss a little bit later also in person to person, but maybe it's something interesting for the community to share. Thank you.
Iain, what can you say?
Sorry, was that addressed to me, Anna?
Yes, there was a question for you from Peter.
Sorry, I missed it. I was, can it be repeated?
Yeah, I can repeat it pretty quickly. Hello, Iain. Thank you. It was an interesting presentation. I just was interested whether there is a need in ESA for strain measurement with FPG or fiber optics in terrestrial or in-space operations. Thank you very much.
Thank you. Well, look, I mean, it's a topic that we've been studying for more than 15 years. And, you know, we clearly are excited about what can be done, but the challenges still remain, even after 15 years of development. And it goes back to a little bit what Lewis was talking about. It's how to get the sensors up to it's a combination of a couple of things, in fact. One is the cost still remains high of this solution. And the other one is concerning the technology readiness level of the sensors in particular, and mastering this in terms of reliability over lifetime, offering calibration over lifetime. And this is still seen as a challenge for us in using FPGs. We would love to use them. We see a lot of potential. We have interest in measuring strain, temperature, pressure, over a wide variety of thermal ranges, from cryogenic to high temperature. But really the challenge is to work on those two areas. One is on the cost, and the other one is on calibration and use of these sensors over long periods of time.
Thank you very much, Iain. And we continue with the program, and we started with space, and now we go to medical. The next company, I think many of you already asked me, they are really looking forward to understand what Endosmart is doing for the minimally invasive surgery. I think we all want to hear from Jessica. Jessica Becker, the floor and the attention of everyone goes to you.
Thank you so much, and I'm also very happy to be here. Can you see my screen?
Crystal clear.
Okay, so now it's better. So yes, I'm talking about another topic. I want to introduce you to Endosmart, so what we do, and I want to present you our new development project. And this is about a retrieval basket with coaxial integrated laser fiber for a minimal invasive procedure in urology. So first of all, some general facts about Endosmart. So we are not a laser fiber specialist or something like this. We are located in Karlsruhe in Germany, and were founded in 2002 by Dr. Bernd Vogel. And we do develop and produce medical solutions out of nitinol, but we are acting as original equipment manufacturer. So we do not sell our products to the hospitals. Instead, we sell it to our PLMs, and the PLMs do the registration process on their own and then sell it to distributors or to the hospital. And through our business model, we do have got a wide range of different products and also different medical applications. We are doing single-use instruments for urology, as you can see here. These are retrieval baskets, and we do also reusable instruments. And another strong area are breast implants out of mesh or out of twisted wires and so on. But our main focus is urology, so stone treatment. And stone treatment, we have got different possibilities. First one is spontaneous stone discharge. So smaller stones go out of the body naturally. But if the stone is maybe too big or the location is not that good, we can use another possibility called URS. And with this possibility, we go with an endoscope through the urethra. And an endoscope has got a light source, of course, and we do have a camera on it. And in addition, we have got working channels to insert instruments to operate. And so we go through the urethra, and then we can catch the stone with a retrieval basket, and you're stone free. Another possibility is ESWL. Here we don't need to go inside the body. We use ultrasound to destroy the stones, and then the stones can go out of the body naturally, as you can see here in the picture. And also a common method is the PCNL. Here we go with also an endoscope, as you can see, through an incision in the skin, and we go directly to the kidney, and then we can again insert a retrieval basket into the working channel and get out the stones. But sometimes stones are too big to be received out of the body, and this is when laser technology comes. So we can use laser technology for stone treatment, and mainly holmium lasers are used. And here again, we have got two possibilities, the possibility of dusting and the possibility of fragmentation. Dusting means that we are using laser energy to destroy the stone, and we produce small particles like sand. And the second possibility, fragmentation, here we fragment the stone and the remaining fragments are retrieved with the device. And the problem with dusting is that the small particles remain in the body, and all remaining particles are source of new stone formation. And this is why dusting is criticized a little bit. But we also have got some issues with fragmentation. So the first issue is that we do have to use two devices. So we have the laser fiber and the basket. So first, the laser fiber is inserted into the working channel of the endoscope. We fragment the stone, and then we pull out the laser fiber and go with the basket through the working channel and catch the stones. And this is not very good handling for the surgeon, and it costs also time. And the second issue is that the stones are jumping through the pulse wave. And so it may be that the surgeon has to detect or locate the stone again. And this also increases the duration of surgery. So because of these issues, we are currently working on a new development project. So we want to develop a retrieval basket with coaxial integrated fiber for URS. And we want to achieve an outer diameter of 1.9 French. This equals to 0.63 millimeters. And through this development, we see some advantages. First one is that we can position retrieval basket and laser fiber exact. So we first catch the stone, and then the stone is fixed. And then we come with the laser fiber, we shift it forward and destroy the stone. And so we can avoid that the stone is jumping away and the surgeon has to detect again. And another point is that the handling for the surgeon is simplified. So we do have just one single instrument, and this makes it much more easier. And also the coaxial technique allows us to use more compact endoscopes. And this may reduce also excess trauma. In general, we are looking for partners who can deliver us suitable laser fibers. And we are, of course, need fracture stability, low loss transmission of the power, even under bending stresses of the fiber. We need good gliding properties, and the fiber needs to be sterilizable and biocompatible, of course. And we also did some testing before, and we fragmented stones with a power from 6 to 10 watts. We used an energy of 0.6 to 1.5 joule and a frequency of 5 to 10 hertz. And this worked, of course, and we used a holmium laser. And we are also interested in getting in contact with people which has access to lasers in order to perform some tests. So this is the end of my presentation. Thank you, and feel free to ask questions.
Thank you very much, Jessica. Super nice presentation. What an application for fiber lasers and for fiber sensing. So, okay, so then you already said what you need. So you need a high-powered fiber laser. We have several companies doing doing this kind of lasers in the room. So, well, I don't know if we can have any comment from Modulight, from Coherent, and Kati. I know, for example, Elena is in the room. Eblana Photonics. Thomas.
Yes,
Hello,
hi.
how are you doing?
Doing good, doing good. Thank you, yeah.
Do you see any room for collaboration with Endosmart?
Sure. I think if they're using thulium fiber amplifiers, it could be a possibility.
Yeah, we thought already about this opportunity to use a thulium laser. Yes, but I think it's not ready for market, or do I see it wrong? What do you think? I thought they were developing the thulium lasers. Not yet.
Yeah, I think, sure. I think there are a few companies that do manufacture thulium for this application. So maybe we can talk after the meeting.
Okay, perfect. Thank you.
Thank you.
Okay, so yes, we will make sure that you get an introduction. Okay, so other questions, other companies doing this kind of lasers that would like to talk now? Okay, hello. Neverre Flore, are you?
Yeah, I just wanted to ask why 2.1 micron? Is there a specific need for this wavelength?
Excuse me, I didn't get it.
Why do you use 2.1 micron wavelength?
So the question is why we go to the holmium laser. So holmium lasers are mainly used in urology to fragment stones. So this is the standard, the gold standard, I think. And thulium lasers are coming, but they are not common yet and not developed yet.
Okay. And do you need a fiber laser or also a delivery fiber?
So we do need a fiber, not a laser.
Okay. Okay.
Yes. We want to deliver our PLM, so our customers, single-use instruments, so the retrieval basket and the laser fiber in it. And then the PLMs go and sell it to the hospitals. And the hospital do have these lasers. So we don't want to buy lasers or something like that. But we need someone with a laser to test our system.
Okay. So we should have a discussion because we already are developing fiber solutions for 2.94 micron laser, erbium YAG laser, but our fiber are even more transparent, 2-3 dB per kilometer at 2.1 micron.
Okay.
And I know it's the best transmission among all technologies, as I know.
Okay, perfect. Thank you. Would be great to talk to you.
And we handle 1.5 joules, multi-mode, not single mode. I don't know what are your requirements, but we should discuss later. I don't want to bother other people.
Okay, and also I can see Slava from Art Photonics raising his hand. It's right, yes.
Just short question, because I'm watching this technology for more than 30 years, I should say. It was started with Alexandrite laser, you know, in University of California. So, and right now, choice of the proper wavelengths must be always based on the principle that you will really make the smallest particles. Because you already mentioned when the, how to say, stones are too big, it's really dangerous for the patient because they have a very sharp edges. So that's why question to select the proper wavelengths was already not in our hands. You know, we deliver only fibers, but a company IPG, Photonics, you know, they develop kind of laser fiber, erbium. It's two wavelengths simultaneously, and you can play with them because stones are not of the same composition, and you should adjust, let's say, ratio of wavelengths to minimize average size of the particles after this lithotripsy. So that's why when you really made your selection just because holmium is accepted, it's nice. but is it the best?
Okay, perfect. Thank you for the hint. Yeah, we will think about this. Thank you.
Okay.
Okay, very good. And then I am sure there are other companies in the room thinking, I think that I am also can provide this technology. Please contact me after this meeting and we will provide you an introduction with Jessica. Okay, so thank you very much, Jessica. A very interesting application. I'm very impressed. And now let's go ahead with the program. And our next speaker is Remco from Somni. Okay, Remco, very good. If you can go to presentation mode.
There it is. So welcome everybody. Everybody can see my screen, I hope?
Yes, but not in presentation mode yet.
I'm not in presentation mode yet?
No. Maybe you didn't share the right screen.
How about this one?
Not yet.
You can see my screen?
No, perfect. The floor is yours.
Yeah, okay, great. Well, hello everybody. My name is Remco Nieuwland. I'm from a Dutch company, Somni Solutions, based in The Hague, the Netherlands. And let me briefly tell you a little bit about the things which we are doing. We are a fiber optic sensing company, really solely focused on the sensors. The sensors are using fiber Berg ratings, and we make several different ones for various applications, various customers. So we are active in the medical field with some development projects. We have a number of accelerometers which are being used for railway applications. We're active in the defense field with developments of fiber optic hydrophones. We do some stuff for big science. This is a picture of ITER. I'll come back to that a bit later. And our main field is structural health monitoring. This is a nice bridge of the San Giorgio bridge in Genova, which holds 76 of our nice tilt meters, hopefully to keep this bridge safe for many decades to come. Now, for this presentation, I try to make a combination of the specialty fibers which we are using in our sensors to give you an idea there, and also what we are doing with specialty fibers and what kind of developments we see ahead. So if you look at, for example, our accelerometer range, these are two of our accelerometers, especially the small package. Here we are using the bend insensitive fibers to avoid bend losses inside the sensor and to be able to concatenate them to very large range fiber optic sensor arrays. Well, these are, well, I call them specialty fibers. They're still fairly standard. If we go to other applications, for instance, what we do for ITER, there we are developing or have developed the temperature sensors going up to 300 degrees C in a rather small package, total diameter of 3 millimeters. And those fibers which we're using here need to be radiation hard, at least the whole package needs to be radiation hard, but also vacuum compatible. And the same applies for accelerometers, which we are delivering for ITER. They need to be able to operate up to 170 degrees C. Also here we are using the radiation hard fibers, and of course it's a must to be vacuum compatible. Now, if you take a closer look at those accelerometers, what makes them different from our standard range is well, firstly, the width of this sensor. We made a lot of modifications to our standard accelerometer to be able to deliver this. But one of the most striking things you see immediately is that the width of this package is a lot wider compared to our standard accelerometer. This is the reason for this is because we are using those radiation hard fibers which are not bend insensitive, and therefore we need to make them wider simply to accommodate a larger bend radius. So if anyone's out there with a radiation hard bend insensitive fiber, I would like to hear about that. The other thing which we are seeing as Somni, so we are the guys who are developing the fiber optic sensors based on fiber break ratings. We see the developments in specialty fibers, especially going through smaller diameters. And the reason for that is we are experiencing a lot more signal strain with the equal amount of force if we reduce the diameter of the fiber. Simply reducing the diameter of a standard 125 micron fiber to 80 already gives us times more sensitivity with the same amount of force. And if we reduce that further down to 50 micron, and this is commercially available, we see 6.25 times increase in sensitivity with respect to the same amount of force compared to a standard 125 micron fiber. However, for some of our customers, this increase in sensitivity was not enough. So there we needed to develop a fiber which is 25 micron in diameter. And that gave us, of course, some headaches. But the plus side here is we get 25 times more sensitivity out of this fiber compared to the standard 125 micron fiber, which is really fantastic. But then, yeah, you might be asking me, okay, that's very nice that you've got this fiber, but how are you handling such a small diameter fiber? How do you do that? The stripping of the coating, the cleaving, the splicing, and also the FBG manufacturing? Well, I've got only a few minutes, so I won't make it too long. But yeah, we developed processes in-house to do the stripping and the cleaving and the splicing. I got some examples here. So here on the left side, we've got a 125 micron fiber spliced to a 50 micron fiber. I think most of you can do this in-house. But here we go from the 50 micron fiber to the 25 micron fiber, and yeah, that I can assure you this is quite tricky to do. And after that, when you can connect it to a standard fiber, you want to make fiber break ratings into such a small diameter fiber, and for that we are using the Noria, the FBG manufacturing station, which is sold by the guys from Northlab in Sweden. The process which we develop here is really meant for lab purposes. Scaling it up to industrial processes, yeah, that's something where we really need to have partners once we are in volume production to even get there. So I hope that gives you an idea on what Somni is, what we are doing, and yeah, if you've got some questions, please. Shoot.
Thank you very much, Remco. Thank you all. I keep saying that you are one of the examples of innovating with a supply chain of EPIC members. You talk about the Noria. I also showed the video about the Genoa bridge, in which you have been collaborating with Sylex and with the GHT and with another one which I'm gonna come in a second.
Luna.
Yes, with Luna Innovation. Yes, thank you. So you've been really one of the innovators on this. I'm going to introduce you to companies to innovate with. I'm going to do it like this. So first I'm going to go to Lannion. I'm going to go to Lannion because Nicephore, iXblue, I really want you to show what you can do now, because it's for me clear room for cooperation between the two of you. Nicephore, you have one slide to show us, right?
Yes, thank you, Jose. Thank you also for the nice presentation before. I think we certainly can find some collaboration. So I just wanted to share one slide about two examples. I think it's coming now. Can you see it?
Yes.
Yes.
Okay. So just wanted to share one slide with two examples of what
you're showing the wrong screen. So you go there to parameters d'affichage, and then you can switch the screen that you are seeing.
Ah, okay.
So they are in the screen a bit higher up.
Sorry.
Yeah, there, exactly.
Okay.
Pascule.
Better.
Sabo, yeah.
Sorry for that. So just to share with you two examples of what we can do to tune a fiber, I will say, to a need. So first example is a sensing fiber. So here the idea was to make some very small, tiny coils, like 30 millimeters, 40 millimeters diameters coils for fiber optic gyroscopes with a high polarization extension ratio. So what we need to do was to increase the fiber birefringence, even with a small bending in these coils. So what we do,
there is some kind of zoom that doesn't allow us to see the full slide. And for me, this is so important to show that what we're gonna do is do not do presentation mode, just skip, press escape, and then see it directly like that. Show it like this.
Better like this?
Yeah, better like this, yes.
Okay. So what we did is that we modified the fiber elliptical clad of the fiber. We are working with a tiger type fibers.
Apparently you pressed a button and the whole thing went. This is the beauty of life. I really enjoy this because you could record the presentations, nothing would work. So I'm just talking while you just press escape. I don't know what you're doing. Look, Nicephore, what we're going to do is I'm going to get my back office team to call you and to arrange this. No, like this. Don't touch anything. Just start talking. Your hands behind your neck. Start talking. The floor is yours.
Okay. I can try with the hand like that. No, so we modified the elliptical clad of the fiber, and by tuning it, we were able like that to improve the polarization extension ratios of these small coils of 300, 400 meters fibers by 5 dB, which is a very good performance over all the temperature range from -40 to 80 degrees C. So this is one example. And the other example I wanted to share was on dop fiber. I think Iain talked a little bit about that earlier with erbium fibers or erbium ytterbium fiber. So in order to make a space amplifier. So here we had to work on the right doping absorption level of the fiber to meet the power budget. We also need to work on the fiber codopant composition to reduce the gain fluctuation with the radiation. And last point was to work on the fiber coating, of course, for long-term operation at very high power, because the idea was to make a booster amplifier for space to Earth link. And this is what you can see on the below graph, is that we really improve the reduction of the gain amplifier versus the radiation with the various generation of fiber. So this is just to give you two examples of what can be done either on the geometrical aspect of the fiber, and I think this is linked a little bit to the presentation we just see.
Thank you very much, Nicephore. I think this is a clear room for cooperation here. In the presentation from Somni, we saw actually, Remco, you showed us this and we loved it. Is there any potential room for cooperation, any challenges, any question that you have for iXblue?
Yeah, you can see that we have an interest in the radiation hard fibers for our customers, and there are a lot of discussions going on about different radiation levels, and I am not a nuclear physicist, so I'm looking at those numbers and I'm a bit clueless. So yeah, I would really appreciate to have a discussion with you guys to see what your experience is and what the actual practical limitations are in this fiber. And of course, we would definitely like to be able to shrink down our sensor size, and I'm hoping you got some sort of solution for a bend-insensitive radiation hard fiber.
There is obvious room for cooperation here. The fibers from iXblue for radiation sensitive fiber from iXblue are endorsed by Luis Ferreira from HBK Fiber Sensing. So that means that they are fantastic fibers. I'm gonna now go to another potential cooperator for Remco. I'm gonna go to Cailabs. I'm going to go to Cailabs. When it comes to beam shaping, you have working in few mode fibers. You are copying to actually going from different fiber size of the core. Arnaud, you have one slide for us. Let's identify room for cooperation.
Okay, thank you, José, for the introduction. So as you say, the Cailabs is a company that is focusing on shaping the light. And we use this in multi-mode fibers for mainly telecom application for spatial division mode multiplexing. And
you have a slide, right?
Yes, and
because we cannot see it yet. So let's put it here so we can see it while we hear you.
And what is interesting is that this technology can be used also for other potential and for sensing potential application. So the principle of using this technology is that you are able to address individually each mode of a multi-mode fiber. So what you do is you have a multiplexer, demultiplexer, that is able to access each mode of the multi-mode fiber, and you have one output or input that is addressing this fiber. It means that each mode can then be a single detector for the sensors. So that means that it could be interesting for sure for FBG sensors, but also for vibrating sensors or pressure sensors, things like that. So it means that at emission, each mode is addressed individually, and at reception, each mode is measured individually. And so this kind of technology is gaining some interest to improve the sensing and improve especially, you can with that decorrelate the temperature and strain in the fiber sensing. You can use this also for multi-mode specialty fiber sensing. And in terms of application, it could be used for strain sensors, harsh environment sensing, biosensors, and vibration and acoustic sensors.
One thing that for me impresses me a lot from Cailabs is what you have done for the few mode fibers you have done for going from different multi-mode fiber assemblies on the datacom, on the fiber lasers, and now also in the fiber sensing instrument. So I'm gonna go back to Somni because of course my job is really that you guys work together. And I love when my friends work together, by the way. Arnaud and Remco are personal friends of mine. I'm not gonna hide that. Today, Remco, you were talking about reducing more and more the diameter of the fibers. I really was fascinated by this development. When it comes to different approaches to do, for example, multi-core fiber, to have different small cores into one single fiber, is there perhaps some room for cooperation here?
Yeah, the interesting thing about the multi-core fibers, that I'm intrigued by your comment about the independent measurement of temperature and strain, because that is something which we of course are always fighting against. Every single sensor we make is not only sensing the parameter which we want to sense, but also temperature, and that can give us quite some headaches. So yeah, this is really a topic I would like to discuss further with you.
Fantastic. Multi-mode, addressing individually the modes, multi-core addressing individually the cores. These guys can do it, and they do it fantastically. I'm really impressed by Cailabs, I have to say. I'm really impressed. And I'm going to go to another collaborator for you, Remco. I really love this. I'm going to go to Berlin now, and I'm going to go to Slava Artyushenko from FORC-Photonics. Slava, you also have one slide to share with us. Let's identify some room for cooperation here. I think we are still muted, so let's unmute. You are still muted is the sentence of the year for me. I'm printing t-shirts with my face and saying you're still muted. Yes, Slava?
Okay. Did you see my slide?
Yes, crystal clear.
Okay. Just because of, let's say, only one slide, 1.5. I would like just to confirm that we are for more than 22 years in business with any type of fibers where you don't see fluoride glass fibers because we couldn't cover too much. But we have unique mid-infrared fiber, which is nanocrystalline structure made from silver halide crystal extrusion, and they are the best for the range up to 16, 17 microns. You can see this kind of red curve over here. We also work with chalcogenide. That's why, for us, when it was Darwin mission, which Iain has mentioned, it was really interesting to provide samples of single mode chalcogenide going deeper in the range up to here. And we are still interested, to work for Darwin again, because it was 2 steps already, and I'm happy that it's not completely dead. It's still alive. Okay, just to mention that for mid-infrared fibers, which are probably not the main topic of this event today, they are unique in the field not only for, let's say, sensing like vibrations, pressure, what else, but kind of unusual stuff. You see here a picture of bundle in mid-infrared, which can be used for infrared imaging. So this is Optris camera. And we are nevertheless more focused in the field of spectroscopy. So with silica fibers, we can make with a Raman spectrometer single fiber needle probe, which is only 160 micron in diameter, which can simply measure Raman scattering and fluorescence through the same needle where the laser beam comes through. It's for cancer diagnostics. We do it with company Revert and Erasmus Medical Center in Rotterdam. But here you see picture of, let's say, any kind of spectrometer. So FTIR from Mettler Toledo, Raman, fluorescence, near-infrared. And we really proceed with search of the best method to make process control, like, for example, in brewery, fermentation in brewery. Can be anything else in chemical, in food industry, and so on. But our, how to say, strategic goal is really to go from, let's say, research instruments like multispectral fiber system to the customized devices. So you see here a tiny device where data are transferred to the cloud, and it's used for the moisture monitoring. And thanks to EPIC, we have now interesting contact with Multispectra, with Telecom tomorrow, to see how their chip can be united with our fibers to make excellent, let's say, spectral fiber sensors, which can be used like Internet of Things. I believe that this is the future. So it will be a lot of sensors in critical points. Data will be transferred by Wi-Fi or what else, to the cloud, and end user will get precise knowledge about process, how his sugar plant in Cuba is doing drying of sugar, something like that, So sitting here in Berlin, in Brussels, or what else. So that's why only half a slide I promised to show as well. I don't know how to change it. Okay, oops.
It was, I guess, the last slide. You had half a slide. I'm super curious of what you wanted to show us. I know it was something impressive.
Yeah. I think if you see right now the slides, then
we no longer see your screen.
Okay. Sorry, but in general, it's simply data from marketing agencies. If I can show it, just a second again. Share screen. Yeah. You see it now?
Yes.
Okay. It's 2 tables. It's not from us. It's just from the agency, and if you would like to believe to BCC research or not, it's up to you. But in general, it's market for photonic sensors, which is predicted up to this year. It's good time, to check how correct these predictions were, but they are really not only fiber sensors, it's any kind of photonic sensors and detectors. But you see, it's predicted very high, let's say, growth, up to 17 or even 19% growth within 5 years. So, and here at the diagram, your attention probably will catch biophotonics, because
Definitely.
You see it's 30%, while information technology is only 23.
Disposable endoscopes, that's the market that we need to push. We need to push that one. That's a huge opportunity for this sector. But in your slide, Slava, I saw a spectrometer from Wasatch Photonics, and they just joined EPIC. So Dieter, thank you very much for joining this meeting. You have the fiber manufacturers, sensors, instruments here in front of you. Dieter, do you spot some room for cooperation?
Absolutely. Like you said, Art Photonics and we are and Wasatch are already working together, and they make great fibers, and they this combination sensor they have is just it's a wonderful application of this multispectral approach, right? That's absolutely, this is the fiber sensing goes really well together with the Raman spectroscopy, which is sort of the focus of FORC-Photonics. And what you just mentioned, the endoscopes, right? The disposable endoscopes. I just had a discussion with another EPIC partner last week about this, and I see a great future for that. Absolutely.
Thank you very much, Dieter, and thank you for supporting EPIC. And we go to the next presenter today. We go to Luna Innovations. Let's go to the moon. I know we're super excited when I had to introduce Luna, one of the hard companies in the fiber sensing industry for EPIC. Thank you very much, David, for being with us this beautiful afternoon. The floor and the attention of everyone goes to Luna Innovations.
All right, thank you, Jose. Is my slide coming through okay?
Crystal clear.
Awesome. All right. Again, yeah, thank you. It's a pleasure to be here. Again, my name is David Potter with Luna Innovations, and what I planned for this morning was really a relatively high-level overview of the different areas that Luna is involved in this space, and focusing a little bit more on the fiber optic sensing. All right. Yeah, Luna is a worldwide organization, and we have a growing portfolio of photonics and fiber optic systems. Kind of fall out into two basic areas. One, of course, is fiber optic sensing, so measuring strain, temperature, vibration, acoustics, pressure, things like that. And then the other kind of half of our business is focused on what we call communications test and photonic controls. And let me kind of expand on both of those a little bit. So as I mentioned, the fiber optic sensing, of course, I'll talk more about the specifics of what we have in that portfolio. But again, focus on aerospace, automotive, infrastructure applications where kind of enabling new types of measurements using fiber optic sensing is key. On the communications test side, there we're involved in really two areas. One is supporting developers of photonics and communication systems through innovative and advanced test and measurement products, and then also with a growing, supporting this side with a growing portfolio of building blocks for developers of photonic systems. So kind of if we drill down into that side real quickly, we offer a full suite of instrumentation products, which allow you to see with very high precision, kind of looking at the, I'll say the media layer of the optical path, looking at loss versus length with super high resolution, analyzing polarization. And then, as I mentioned, we also have a growing portfolio of what I call building blocks for photonic systems, with a particular focus on polarization control. So we have a full suite of modules, for example, for polarization tracking, stabilization, and monitoring and things like that. Also lasers, tunable filters, and variable delay controllers, for example. And then switching kind of back onto the fiber optic sensing side, we kind of that breaks down into, we have fiber optic sensing systems, and then also a terahertz gauging and imaging platform as well. On the fiber optic sensing front, we have 3 new platforms and have some news which I wanted to highlight. About a month ago, we brought OptiSense on board. So OptiSense is now part of the Luna family. If you're familiar with OptiSense, then you know they're a leader in the area of distributed acoustic sensing. So as you can see here, they offer a vertically integrated solutions from lasers through the Rio Lasers brand, which some of you may be aware of, through interrogators, software, and full system deployment, all based around distributed acoustic sensing as the key technology. So if I step back out and look at Luna's fiber optic sensing technologies and kind of the area and technologies where we're working, we have 3. So on the right, there is the OptiSense technology that I just mentioned that we just brought on board. Again, distributed acoustic sensing, so that they've had a lot of success in long linear asset monitoring applications, pipelines, transportation, railways, perimeter security, for example, as we kind of move. The Odyssey platform is also based on relay backscatter and it's distributed sensing, but it's very unique in the marketplace in terms of the high spatial resolution. So we use a very, I guess, advanced OFDR technique to resolve strain and temperature down to 0.65 millimeters resolution. So on a 50-meter fiber, for example, you can get thousands of sensors with a regular unaltered fiber. So we're seeing a lot of interest and working with customers in areas where that level of detail is particularly valuable. So for example, right now, developing electric batteries, the ability to see temperature throughout the battery and within the battery with very high resolution is an interesting application there. And then the third platform is our FBG Hyperion. So it's a fiber bag grading interrogator. Also can interrogate other wavelength dependent sensors such as Fabry-Perot, for example. But this came through us through our merger with Micron Optics. And so this technology continues to grow as part of our portfolio. One of our focuses here is the development of sensors, FPG sensors that are packaged to really maximize the repeatability and the usability of the sensors. And mentioned the Genova bridge. This is the interrogator that's used quite extensively on that structural health monitoring application. So this platform has seen a lot of success in structural health monitoring, whether in civil infrastructure or aerospace, things like wind turbine monitoring and so on. So that's a snapshot of kind of the areas we're working in. I guess predicted the couple of key questions I get from Jose. So what can Luna offer EPIC members and what can EPIC kind of do for us? What are our kind of needs? So in terms of what Luna can offer, so obviously fiber optic sensing systems, but then I wanted to highlight again that we kind of play both sides of the story here in terms of we supply a range of polarization modules and lasers and tunable filters that are used in a lot of that are form building blocks for a lot of innovative sensing systems with our customers. And in terms of what kind of we're looking for, I guess kind of at a general level, definitely we have a very broad portfolio of sensing solutions now. So partners in the application space is something we're always very interested in pursuing, whether on a commercial or the research side. Of course, technology to expand the general capabilities of fiber optic sensing. And continuously we're looking and getting pushed by our customers for solutions for harsh environments. So high temperature, someone mentioned, radiation hardened sensors was mentioned, that definitely is interest of us for us as well. So so that's what I've got. So happy to answer any questions.
Thank you very much, David. Great presentation. Okay, so then you already said what are your needs. I have a question for you. What about, I mean, how do you see the future of photonic integrated circuits in your fiber sensors, so in your interrogators?
Right.
So at Luna, do you see any application or any potential for this technology?
Yeah, absolutely. Absolutely. Yeah. And a certain, segment of our fiber optic sensing business, of course, the ability to, drive down the cost and the size of the interrogator unit is a key and critical for us in terms of getting onto vehicles, onto more aircraft with a smaller footprint and a lower cost size. So yeah, it's critical for us long term. We have some research initiatives pointed in that direction, not surprisingly, but yeah, that's definitely would be another area I probably should have added to the list in terms of where we see a big need for us in the future.
Okay, very good. So now I would like to introduce one of the companies here in the room. If you have any need in simulating these photonic integrated circuits on how to couple the light into the system, we have here Synopsys. So Maryvonne, maybe you would like to explain what is Synopsys doing, and also maybe you have a slide to show us.
Sure. Hello, everybody. So let me share my screen. I guess you have it now in full screen, right? Yes?
Yes.
Perfect. So yes, I'm Maryvonne Chalony. I'm working for Synopsys, and maybe some of you know me and know that I was previously working for Lightech. So, but 2 months ago, Lightech was acquired by Synopsys. That's the reason why now I am a part of Synopsys. So, but it doesn't change that much because Lightech was really involved in the Synopsys business for optical design. So as Anna mentioned, we have in-house solution for optical design from the component to the system, but also we are really pushing a lot for PIC application as Anna mentioned just before. And for today, as the talk was more focused on fibers and sensing, just a few words of the type of studies that you will be able to do using our software. So with our software, and especially the suite called Airsoft, you will be able, using Maxwell Solver, to have all the property of the fiber, and it can be from classic fiber, let's say, so single mode, multi-mode, and from this fiber you can study how it behaves at the level of the component, but you can go up to the system of communication. For example, for a multi-mode fiber, or a misalignment will affect your bit error rate, your high diagram, the mode couplings that you will have on your fiber. At the fiber level, you can study all the eigenmode of the fibers. You can have also much more advanced fiber type. I saw from iXblue some profile of fiber, birefringence fibers. That's something that we can study, design and study inside Airsoft. Some people was talking about multi-core fiber, air-core fibers. That's also something that we can study. Here you can see I have a picture from AFM of hollow-core fibers. Having this picture, I can translate into index profile and perform the mode calculation on this specific fiber. So it's really the fibers that you have in your lab. And to go further, we can also deal with so bending effect on the fiber, how we will impact the transmission. So either on the power or either on the some polarization aspect. Also, really important question for all the audience today, but how we can couple light efficiently. There is different type of couplers that we can design, perform. So of course, simulation software could be a huge help in order to find the good strategies, the good candidates for your application. And then at the level of the sensor, as we have software suite to deal with the system of communication, we can deal with fiber Bragg grating, thermal sensor, for example, design, or it can be also gyroscope design, even radio over fiber to talk about space application. So multi-mode fiber can be taken into account at the level of the system, and we can go also on PIC, and we have a full. So we are developing a full platform for PIC simulation. So that's really in a few words what we are doing at Synopsys, and really so I was focusing my speech about fibers and sensor, but if you have any other challenge on optical design, especially if you have dealing with challenge in between photonics and optics, we have in-house a lot of developers dealing with Maxwell equation, with ray tracing software, and we are really the right people to talk about your challenge when you are dealing with microstructure, photonics, PIC into a large optical design. Thank you.
Okay, thank you very much, Maryvonne. So yes, for these companies that have needs for design fibers or photonic integrated circuits, we will be very happy to connect you with Synopsys. Okay, and now I would like to give the word to Photonics Britain, David. Are you here? Would you like to explain us what are the activities, the core activities of this Photonic Hub?
Yeah, sure. Hello, everyone. Yeah, actually, I might have even a slide to share, maybe, just
Perfect.
to explain in one slide. Do you see it?
Yes, we can see it.
Yeah. But basically, we are some kind of RTO making optical fibers, as some of you. And we are specially dedicated to the fabrication of photonic crystal fibers. So we can make any kind of photonic crystal fibers from, well, sensing application, laser application, can make solid core, hollow core, multi-core. We were talking about multi-core. We can make also a very large mode area fiber, terbium fibers. So our main business is really the custom fiber development. So if for your sensing application, you need a fiber that is not available on the shelf, then you can ask us, and we can pretty much develop any kind of like custom fibers with a very some kind of a specialization on photonic crystal fibers. We can also make capillaries, stress rods, fiber tapers, fiber combiners, from the conception to the integration. So we have brand new facility with drawing towers, MCVD latte, phase vapor deposition system. We can also do simulation of modes in optical fibers and any kind of characterization. So we are very good partners with iXblue, which is like our neighbor. We are also interested by any kind of specialty coatings. We can also develop specialty coatings for harsh environment, for example. So for any kind of special need on PCF and specialty optical fibers, feel free to contact us, and we'll be very happy to help.
Okay, thank you very much, David. So yes, for these companies in the room with needs in customized fibers, we'll be very happy to connect you with Photonic Britain. Okay, so now let's go to our next speaker. So we are going to hear about the customized fibers, fiber design from MBG. So Patrick, very good. Perfect. The floor is yours.
Thank you for the very kind introduction, and hello also from my side. I hope everybody can see my screen and can hear me loud and clear. Is it okay?
Yes, yes, we can see. Yes, everything is okay.
Okay, great. My name is Patrick Weisinger. I'm from MBG in Austria, and we are providing mainly fiber optic tubes and cables, as well as fold sensing projects based on optical fibers for many different applications. And in the previous presentation, I've heard that cable designs for optical fibers can be sometimes very challenging for the sensing applications. For example, the thermal coefficient mismatch between different components. And this is exactly what I want to address with my slides below. I think this initial question came from Isa before then. So as you know, a very basic fiber optic sensing solution consists of at least 3 components, which is the sensor itself, the interrogation unit, and the software for the signal processing and visualization. When, for example, project owners for such sensing applications come to us and want to buy a cable for distributed sensing, we often hear that they have a specific interrogation unit and the best software existing for getting the most accurate data out of a specific field, for example. But when they ask about the fiber optic cable, we really often hear that we just should provide a standard fiber metal tube with a specific fiber because the design of the cable doesn't play a very big role for the system. And in the next couple slides, I want to briefly explain why it really would make sense to pay extra attention to a specific cable design and why we as MBG and Solifos have a specific focus to develop tailor-made construction to get the most out of a sensing job. As you know, a metallic protected fiber optic cable consists of at least a metallic tube and the optical fibers, which is the fiber and metal tube at its very basic construction. But there are way more components and parameters which can be critical for the project environment. These parameters are mainly differentiated in the mechanical durability and the distribution of as the factor of the measurement signal all the way to the sensing fibers. A single layered film, for example, will react very quick to temperature changes, but has a very bad mechanical stability, while a robust cable, like you see here on this chart, for example, reacts slower, but is more protected against the auto influences. This is just a small example which represents the basic requirements of a sensing cable design. The main components we basically pay at most attention for creating the right cable design is mainly the dimensions and the grade of the different steel materials and polymers, the reinforcement with the steel wires, and also the filling compound, which has different tasks like excess fiber length locking, hydrogen blocking, and blocking water distribution for subsea application, for example, when the cable is getting damaged. All those components can, of course, be mixed and integrated in a cable design in order to withstand high mechanical forces and provide sensitivity and high quality light transmission. Beside of the layer design itself, the way how the fibers are embedded inside the cable is mandatory, especially when the cable is facing elongations and retractions due to the temperature influence, like, for example, we heard before. To compensate this thermal coefficient mismatch between the cable components and the optical fiber, it is very important to build up the so-called excess fiber lengths. On the right side of this chart, you can see the different stages of excess fiber lengths inside the longitudinal cut schematic of a FIMT. Number 3, for example, represents the low excess fiber lengths compared to the tube, which doesn't allow a lot of temperature changes to keep the fiber strain-free. While number 2 in this picture, in the middle section, a very high excess fiber lengths, where the limitation is the minimum bending radius of the fiber to avoid the critical bending losses. So the goal is now to find the right setup value when a cable is being manufactured, and therefore the knowledge of the environment prior to processing the cable plays a huge role for the final sensing quality in the field. And of course, there are many more parameters to pay attention besides of the excess fiber length setup process, but this is more or less the frame which is very important to take into consideration. In the second part of this presentation, I want to show some specific cable design which are developed and optimized for the different sensing applications. Here on this chart, for example, you can see the newest sensing cable in portfolio, which is optimized for very accurate distributed acoustic sensing, while the fiber is protected with a metallic tube. The advantage of this cable design is how the fiber are mechanically bounded and coupled with the metallic tube, and the property of the material grades what we have used for this cable design. For example, we are using a polymer grade with special additives on top of the fiber and metal tube, which has the target to allow a very high transmission rate of the acoustic signal. Also, we created defined holes in the metallic tube to gain the intensity of the signal, as well as to avoid the propagation, to have a very sharp and intense signal in the end. The target of this specific cable design is to measure the elongation and retraction of the components where this cable is mounted. In this design, the fibers are accurately clamped into inside of a very tiny fiber and metal tube with only 1.3 millimeter in the outside, to measure the strain, but also measure temperature and other values at the same time. And because of the asymmetrical alignment of the 3 fibers in this design, it allows to perform shape measurement, which can be used for structural health monitoring, for example. And this is a project what we have done together with Luna a couple of years ago. Our clients are using this cable either as a standalone cable where it is embedded into the application. For example, they are putting that into the concrete or into the asphalt, or they're using this as an intelligent part of a bigger cable construction, like for example, in an umbilical cable to show the behavior of the embedded cable design and look of about the health of the cable actually. And the last design, which is very interesting, and I want to highlight in this presentation, has some very interesting features. When we talk about temperature measurements, for example, we definitely want to catch even the tiniest deviation of temperature. So in the best case, we want to have the sensing cable at a very constant temperature level. But in many applications, the sensing cable is cycling in the temperature like the surroundings. So a way to prevent this behavior is to actively heat up the cable to a specific temperature. And together with Solifos, we got a very interesting design here. And this is a feature which can be achieved with copper elements inside of the cable construction in combination with a specific control unit. This makes the cable design great for long lengths and high accurate temperature monitoring projects, like the one in France on the picture, which you can see here on the right-hand picture, where the cable is looking for leakages of the water canal. And that's all from my side. Of course, there are many other information available for specific cable design and projects, but this brief overview of the different cable designs should show that the design of the sensing cable is a very critical element which needs a special attention to get the most out of the project.
Thank you very much, Patrick. Fascinating, fascinating. But we had before, I don't know you remember, a request from Luna. Luna was saying we want to have a partner that can actually measure high temperature in harsh environments. The reason why we actually placed you here is because we really thought that that could be a match. Did you spot there some room for cooperation perhaps?
Yes, definitely we do. And we are working in many different applications where this application take profit out of a specific cable design. And what I have heard on one of our previous speakers is that they are dealing really with high thermal coefficient mismatch between the fiber and the metallic components or different components in a cable. And we have addressed this topic a couple of years ago, where we came up with a design where we have 3 loose tubes with the fiber inside, and we actually strand these loose tubes and make another cladding layer on top of that. And this goes in 2 directions. One of the directions is a very high temperature. So we have successfully measured with this cable up to 550 degrees C in our laboratory. Also clients are using this because it breaks the barrier of excess fiber length limitation, of course, because the torque of the inner tubes adds another value of excess fiber length inside of the cable. But it also goes in the different direction, the minus temperatures.
One question, Patrick, are you automotive qualified?
No, we are not working that much in automotive so far, more in the aerospace.
Okay, because I do see, well, I have some people asking me about this, so there could be some room for cooperation. For the next speaker actually is already complementing your cables. There is clear benefit on this meeting. I'm going to go to Belgium, to Bram van Hoo, VGS. I know, Bram, that for you, the shape sensing is becoming a very interesting market. It was mentioned a couple of times during the meeting. How are you seeing this market and how is a VGS addressing it?
Thanks for the question, Jose. Multicore fibers and shape sensing, are indeed picking up, or that activity has picked up a lot over the last years now. And we're actually combining their multicore fibers with Bragg ratings. And the Bragg ratings are inscribed during the drawing of the multicore fibers. So it's a very specific technology, combining the specificities of the multicore fiber with the grading inscription in one process step, let's say. And of course, there are many other things coming into play, cabling, connectors, interrogators. So, it's only one piece of the overall puzzle to come to a shape sensing solution in the end.
Brian, I keep complimenting you, but it's because I'm amazed of what you are achieving. pulling your own fiber and going all the way to deploying into so many different markets. And what you're doing in the shape sensing is out of this world. This was a fantastic meeting, and I'm having so much fun. I'm going to go to the final speaker. Everything would actually have an ending. We're going to go to Slovakia because it's one of my favorite countries in the world. And there is one of my favorite companies, Sylex. Thank you very much for sending us away after this fantastic meeting. The floor and the attention of everyone goes to Slovakia. I really love Slovakia. Peter?
Yes, here I am. I'm just sharing my screen. I hope it's went through very well.
Let's go presentation mode the way Anna likes it. And I think we'll be ready for business. Yes, the floor is yours.
Perfect. Okay. Hello, everyone. Thank you, Jose and Epic, for organizing this meeting. And my best greetings to everybody in the room. And I've seen many friends already. That has been very nice to work together through Epic or individually. And I like to be here. And I just want to share with you a few slides. I will be going through them a little bit fast because it's some more pictures there. But in the end, we can stop by and discuss about what everything we might need from the industry and from this cooperation with you all and what we are offering as well. So here we are. Sylex is basically a fiber optics company for 25 years already on the market. And we have basically two divisions. One is focused on interconnect products. That means fiber optic connections between active devices, meaning very specific cables. I will show you some industry examples in a while. And the second division of Sylex is a little bit younger, but yet it's already a nice batch of experiences over more than 10 years manufacturing industrial FPG sensors for various applications and markets. I will show that as well. Because we are a manufacturing company, that's also a nature of us. We provide an OEM services, and I would like to talk about it a little bit also in the end of the presentation. So here we are with the typical market examples. There are some datacom, telecom, harsh environment, defense application for the cables, for the sensing application, where most of you are also aware of civil structures, geotechnical, oil and gas, marine subsea. Those are very typical applications where the fiber optic has been present for 5 to 10 years already. Renewables market is as well very important, and custom built and R&D is also something we provide to many of our partners. Here we are with some examples of the interconnect products, and we are also proud to participate in CERN organized projects where we have delivered a large number of Sylex interconnecting high-performance cables to download the data from the really high-end experiments. Some of them has been participating to find the Higgs boson as well. Then we have some other multi-fiber connectors and connectivity that is typically used in data centers or in simulation supercomputers. We have as well shuttle systems that are very complex fiber management systems. You typically handle more than 1,000 fibers in various configurations. That is very demanding for the production and quality control. And we serve with these products to many the photonics industry and Silicon Valley applications. Speaking about sensing and structural health monitoring, here are some real-life examples. All these photos are not, let's say, artificially downloaded from general databases of photos. These are real projects instrumented with the sensors. Many of those are more than 5 years in use. We have been able to make those products fully industrialized for these environments, no matter what the weather is like there, no matter how the cable connectivity might be difficult. That's a very strong side of Sylex offering, that all the systems are basically plug and play and easy to install, even for people that never worked with fiber optics before. That we see as one of the biggest advantages of these systems and products delivered. A little bit more challenging environments is, of course, when you go a little bit underground. So we see a little bit dirty places of sewers, but on the left bottom side, you can see products that have been used in hundreds of pieces in tunnels and sewers. These have been fully developed at Sylex to meet those demanding and harsh environment conditions for quick installation, so that the people can leave the sites very quickly. We have as well pressure sensors to monitor industrial pressure or even porous pressure systems. Oil and gas is as well an environment that requires fiber optic sensors. So these have been really installed on several pipelines or gas lines in Europe, and further with plug-and-play cables. Actually, this one sensor you see here, it's a spot welded state sensor with temperature compensation that has been as well used in a Geneva bridge that has been already mentioned by Remco and David earlier today. So we see very attractive projects that has been shared between multiple companies cooperating together. That is very good, and we really like to see this cooperation model with similar companies like we are. That's always good, and we believe that the industry in general can benefit from such kind of collaborations. We are getting even more challenging here. So we speak about some offshore applications, even with dynamic measurements, soil field sensors. On this bottom right side, there is a marine grade displacement sensor that can be wrapped around a pipeline in a sea application up to 40 or 50 meters depth. That's as well a real life project, and unfortunately we cannot share more photos due to the confidentiality so far, but it's at least to show up really the challenges that we are facing when using the fiber and the FBG technology as well. And to sum it up, fiber optics is of course part of the photonics industry. That's why we are here all together. And fiber is basically all around the globe right now. We can say it works like a nervous system of the earth already. And from top of the mountains, as we see on the left picture, which is again a real life installation of our sensors on a glacier in Switzerland, in Alps, down to the seabed installation of our marine grade displacement sensors. Those are really from the top down to the bottom locations where the fiber has been already being used. And how do we work with our partners? Why we can make all of these things? I would say more than half of the businesses of Sylex is in a model of OEM. That means the clients might have already their ideas about what they need, and they may be are looking for a really good and reliable partner to manufacture all of those products cost effectively with high quality standards. And that's one of the options. The option number two is that there is general idea what needs to be solved, and that's very typical model for us as well, that we step into those discussions with partners. We can bring up all the experiences that we already gathered through other implementations of our products, and we help very effectively, very quickly delivering first samples to the client for his approval and qualifying the application. And then we are of course able to help the client manufacture the product. And it really can be OEM with private label cooperation. That's basically, we can say, the majority of Sylex products in the world carries different names, and that's completely fine for us. We are happy to provide those services to our partners. What we are also thinking to develop in the future, and some of these are also maybe coming this year. We think of making the dielectric strain and temperature gauges capable of operating for up to 500 and 600 C environment. That's our own development, and we are also happy to partner up with any R&D companies or maybe with the lead clients that would like to discuss this. That's why I also have been questioning Iain from ESA about the strain measurement. We should be able to bring up a humidity sensor or maybe H2 concentration sensor, which is important for battery storages or explosive areas. And we can also bring up a little bit simpler product that is strain rosette based on dielectric or spot level gauge. What we are looking for as well as partner up with somebody else is of course a multi-core fiber connectorization. That's, we believe, is also a future of for our assembly and connectorization services. We are thinking of bringing up, developing with somebody corrosion detection sensor, which is also a very important feature to be measured in structures. And further chemical sensors are also a possible way where we would like to go. And what about the famous EPIC questions? So what they can do for our clients and partners, this is more as a summarization. We are one of the biggest fiber optic producers in Europe, and all of our partners can basically benefit from our well-established production environment, from our skilled engineering and production team. We have already experiences from transferring the ideas into products. And what we are basically looking for from our partners or potentially suppliers or even lead customers is, of course, somebody who can use the benefits and the capabilities of our company and has some ideas of maybe new generations of fibers, and we would be happy to build the first applications with them. And somebody who can also help us opening up new applications in new markets that we are not much present in so far. And I've listed some examples like space industry, automotive industry, process control industry. So this is us. We are a company of a size of 250 people. We serve more than 200 customers per year, and we have a large manufacturing capacities. And this is our beautiful company with a team. And yeah, we look forward to your questions and potential.
An extremely innovative and extremely collaborative environment, and we are so happy that so many EPIC members have gotten in touch with Sylex and co-developed products. It's so great to have you, Peter. So great to have you. I already have many people asking me for cooperations, especially on the ramping up for the volume production of the sensors. There is clear room for cooperation here. I am going to finish the meeting with one thing. Axel Bertholz has something super cool to show us, and he's looking for partners. Axel, show me that medical sensor that is so fantastic. Axel Bertholz, I think we have you muted. Yes.
Unmuting me. Hello, I am Axel from Switzerland. Do you hear me?
Loud and clear.
Can you let me know how do I share my screen?
You go to the bottom of the Zoom window, there is an arrow up next to share screen. It's green and beautiful. You click on it and you select the window that you want to share.
Okay.
It's not my first rodeo.
Do you see? No, there has been. Do you hear me now? And do you see my? Yes.
We hear you, but we cannot see your screen.
Okay. I am trying to put share now. Do you see my screen now? With the beautiful medical sensor. There has been a lot of backbreaking sensors during the meeting. I would like to show you a Fabry-Perot sensor, which is actually manufactured and distributed by Abbott, a company in USA, but the sensor itself and the technology has been done here in Switzerland. And this is fabricated in huge quantities and actually is done for atrial fibrillation surgery. If you have problems with your heart and you have to do ablation, then you probably use one of these catheters. And what you see now here is the fiber optic. You have 3 fiber optic sensors involved. And I will move a little bit forward so that we have, this is the device. And here you have now the sensor. You have a flexible structure like a spring. You have 3 Fabry-Perot interferometers. And then the spring deforms with the applied force of the tip of the catheter with the heart, and we measure nanometric with 3 fibers the applied force. So this is actually a disposable device which is made in huge quantities and is an elegant sensor, fiber optic sensor that actually works. This was the only thing I wanted to show you.
I just wanted you to give us goosebumps to finalize the meeting. It has been really a fantastic meeting, really a fantastic meeting. We spotted so many room for cooperation. We have mailing space looking for partners for the entire value chain of the civil fibers manufacturing space. The European Space Agency, one of the highlights of the show, they talked to us about the request for the use mission. We are going to Jupiter. Then Endosmart talked to us about the requirement for fibers for the fiber laser they use in laser lithotripsy the trip C, and that was, they were very specific. Afterwards, we heard from Somni about the demand for radiation hard fibers. From MVG, what a beautiful fiber cables you have, MVG. I was amazed. And they are looking for partners in deploying them in harsh environments. Luna wants partners to measure high temperature at harsh environments. And Sylex is looking for a company that can handle the ramping up on the humidity, H2, and strain and temperature sensors. So much room for cooperation. I just want to say, this kind of meetings make me so happy. All we keep trying to connect the companies, and at Epic, we keep trying to understand what every company does and try to find you the potential partners, suppliers, and customers. Please keep in mind that the most important part of the meeting didn't happen yet. It's the follow-up. So you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-asoc.com, and I will be more than happy to make that introduction. It is all about collaboration. Also, I would like to remind you that the topics for the next quarter for Line Technology meetings are already announced and in the website. Make sure you register for the upcoming meetings. On behalf of a dream team of medical experts, directed photonic experts, laser experts, quantum experts, the best innovation manager in the world, Antonio Raspa, the best marketing experts, and of course, Carlos Lee, the heart behind the European Photonic Industry Consortium, I would like to wish you that you continue at home, you wear the mask, you be healthy, wash your hands, all that, and join the online technology meetings because we love having you there. Until the next time, take good care of each other. Be epic. Bye-bye.